Hi everybody, I hope all of you are doing great. So in today's lecture, we are going to see another very classical problem of dynamic programming, which is called building bridges, right? This is a very famous problem and you can say a follow-up problem of longest increasing subsequence only, what we have discussed in some of the previous lectures itself, right? This is a whole playlist we are going through, so everything is in proper order, right? So if you want to see all the videos, you can like somewhere here, I'll of course provide the link to the playlist itself. You can watch the whole DP series where I'm trying to make DP easy, right? Now you can of course read the problem statement by yourself. I am directly going to the board and I'm going to explain the problem statement directly there, right? With the example test case, right? Let's quickly get into it. So here I have defined a sample test case. You can see in a sample test case, they will first give you an integer n, right? Then they will give you two arrays, right, of length n itself. First array is north, second array is south, correct? Now these two arrays are given to you, right? And you can of course imagine, like read the problem. In the problem, they are giving the x coordinates of cities in north bank of the river. We are basically having a river, right, which is flowing through, you can say in between two banks, right? This is the north bank, this is the south bank, correct? These are the cities from north bank, these are the cities from south bank. I hope this much question is clear. You have to build bridges between all these, like you can say you can build these bridges between all these cities which are given to you. So for example, north bank of 2 can be connected with south bank of 4. It can be connected with it, right? North bank of 2 can be connected with south bank of 4. Okay, I've connected them. North bank of 4 can be connected to south bank of 6, so 4 can be connected to 6. All right. North bank of 5 can be connected to south bank of 1, so 5 can be connected to 1. North bank of 6 can be connected to south bank of 2, 6 is connected with 2. North bank of 3 with 5, 3 with 5, and 1 can be connected with 3. I'm again and again saying we can connect. I'm not saying I am connecting them. I'm saying that we can connect, right? And this is the only allowed thing we have to, right? So what we have to find out, you can see all these bridges are laid out, right? But can you see some of the bridges are overlapping with each other? These bridges actually are overlapping with each other. And if we are having any of these overlapping bridges, I cannot construct these overlapping kind of bridges, right? Basically, what you have to tell me in this problem is the number of maximum non-overlapping bridges you can build. So can you see, if I do not build this bridge, if I do not build this bridge, and if I do not build this bridge as well, can you see all the bridges are not overlapping with each other? And these are the maximum number of bridges I can build in this particular test case if I want all the bridges to be non-overlapping, right? So this is the problem. You have to tell me the count of bridges which should be non-overlapping in nature with each other. Of course, I cannot connect 5 with 1. This cannot be considered, right? And this can also be not be considered, because if I consider these two bridges, then bridges will be overlapping. There will be conflicts, right? So I don't have to select those bridges which are overlapping. I just have to give the count of all those bridges which are making like maximum number of non-overlapping bridges, right? All those, you have to make some bridges such that maximum number of non-overlapping bridges is maximum. You have to return that number itself. Of course, the answer for this test case would be 4, because there are 4 number of non-overlapping bridges I can build if I am allowed to connect all these cities with each other, right? So ith city of north bank has to can be connected with ith city of south bank. Ith of this can be connected with ith of this, right? So 0th of north bank can be connected with 0th of south bank. These kind of test cases they are giving us. They will give us an integer n, north array, of course, south array, right? And ith in all of these north and south, ith of all these people can be connected with each other, right? By ith I mean 0th with 0th, 1th with 1th, 2th with 2th, and so on, right? So I hope the question is clear to everybody. We have to find out the maximum number of non-overlapping bridges, right? Let us try to look at an approach of this problem and let us try to derive a solution of it. So before taking a look at the solution for this problem, let's first understand what do we call a pair of bridges who are not overlapping with each other. You can see, if I'm considering these two bridges, these are non-overlapping. If I consider these two bridges, these are non-overlapping, correct? These two bridges are non-overlapping, right? So can you derive some relationship? You can see, I can call this north of 1, I can call this north of bridge 2, south of bridge 1 and south of bridge 2. So can you see in this test case as well, right? if north of bridge 1 is smaller than south of bridge, you can say north of bridge 2, and at the same time south of bridge 1 is also smaller than south of bridge 2, this type of a bridge is not overlapping. Let's take an example which is contradicting the statement. Of course, you can see 5 is smaller than 6 and 4 is also smaller than 5. So these two bridges are not overlapping. Let's try to take a contradicting example and see if this test case is valid. Just consider this kind of bridge, right? So this is north of bridge 1, north of bridge 2, south of bridge 2, south of bridge 1, right? This is the south of bridge 1. In this test case, can you imagine, देखो यार, north of bridge 1 is smaller than north of bridge 2. That is fine. That is good. That is good. But can you look at this? That in this particular test case, south of bridge 1 is actually bigger than south of bridge 2. North is getting finished before this north, but south is actually exceeding this bridge south. Right. So can you see that we are going to have a crisscross kind of situation if anything like this happens, right? If anything like this happens, we are going to have a crisscross kind of situation, right? And if you can see, right? Of course, like we are going to consider north as, you can say, sorted form only, right? The whole conflict is created by whom? South bridges, like southern bridges, right? So if my south bridge is also smaller than the south bridge of the bridge coming after me, this means that we are not overlapping. If the south bridge of if my south bridge is coming after the south bridge of someone who is coming after me, this means that I'm creating a conflict, right? Let's take an example again. So this is me. My south bridge is coming after the south bridge of the person coming after me, right? So you can see these bridges are like not overlapping, because you can say, imagine, like, this person is before n2, right? n1 is before n2, and s1 is also getting finished before s2 itself. There is no conflict. But if s1 comes here, essentially I'm trying to say, if this is what we are looking at, you can of course see that there's a crisscross happening here. S1 is actually exceeding S2, although N1 is smaller than N2. This means that the bridges are overlapping, right? The bridges are overlapping, right? So I hope you are able to understand that we are trying to target this kind of condition. We are trying to find the pairs of bridges where N1 is smaller than N2, and at the same time, corresponding to this N1, S1 is smaller than S2, right? So this is a type of bridge which is not overlapping, right? Right. You can of course rewatch this part, right? And like this is the whole explanation part for this. Let's try to derive some approach as to how can we detect something like this. Let's look at that. So basically the problem statement is, in this particular test case, I have to select only those bridges which are not overlapping with each other. But to create these kind of bridges, I only want those bridges, I can only have those bridges where N1 is smaller than N2 and S1 is smaller than S2, as the same thing we derived in the previous, you can say, part, right? Okay. So what I have done here, this is the only test case I'm having. 1 can be connected to 3, right? 2 can be connected to 4, and so on, right? I have actually sorted this, you can say, these kind of pairs on the basis of north bank. You can say in this particular way, north bank is sorted, and you can see 1 is paired with 3 now. So 3 is coming along with 1 when this is getting sorted. 2 is coming along with 4. 3 is coming along with 5, just like this, right? 4 is coming along with 6. 5 is coming along with 1. 6 is coming along with 2, right? So I've kept the same pairs together, but what I have done here is actually I've only sorted on the basis of north bank. These pairs, I've sorted them on the basis of north bank. I hope it is clear to everybody, right? That I have sorted this array. This, you can say, you can consider them as pairs, right? You can consider them as pairs which are bound to each other, right? Because this is given to me, I can only create a bridge from 5 to 1. 5 is bounded with 1, right? But I have done what? I have sorted these pairs on the basis of north bank. Now can you imagine, like, can you see this, right? If I am trying to, you can say, select these bridges, let's say this bridge, I am trying to place this bridge and this bridge together. One thing is clear now, if I am selecting 2 bridges, then the previous bridge N1 will always be sorted. Like, it is of course will be smaller than N2 because I have sorted this array on the basis of N1. Yes or no? I have sorted this array on the basis of N1. That's why if I select something like this 2 and this 5, this 2 is always going to be smaller than 5. Unlike in this case, right? You can see if I do not sort on the basis of, you can say this, if I try to place these bridges, right? You can see 4 is not smaller than 1, right? So sorting has done what? Sorting has ensured that n1 case is satisfied, right? That if I try to place these two bridges are satisfied by n1, and just I have to verify the same thing for s2 so that I can place the bridges or not, right? So can you imagine that n1 is satisfied? Now it's time to satisfy s, like you can say south bank. North bank is satisfied, we have to satisfy south bank, because for all the bridges which are on non-overlapping, north bank of previous bridge should be smaller than north bank of the next bridge, right? South bank of the previous bridge should be smaller than south bank of the next bridge. And of course, this is given in the question that these are the x coordinates of all the cities we are having. So x coordinates is always from, left to right only, right? We increment from left to right only, right? So I hope this is clear that I have sorted this array, these pairs on the basis of north bank. Let us see what we are going to do about this south bank now. Let us imagine. So to satisfy the south bank part, just look at this array and try to figure out what is the longest increasing subsequence. S1 has to be smaller than S2. So I'm trying to figure out what is the increasing subsequence. Let's try to find it out, right? I'll select 3, 4, 5 and 6. I think this is the longest increasing subsequence this below array is having, right? Can I say if I am selecting these two bridges, this bridge can come behind this bridge? Yeah, south bank is smaller than the south bank of this bridge, and north bank is also smaller because we sorted for the north bank. I hope it is getting clear to you all, right? You can see this bridge can come behind this bridge because south bank on the base of south bank is increasing subsequence, so this has to be smaller than this. And on the basis of north bank we already sorted, so this is coming behind this. I hope this is clear. So if I am looking at this, if I'm looking at this particular case, right, what am I targeting here? You can see north bank of this, it will be smaller than the north bank of this because this 3 is actually coming before 4. We sorted on the basis of north bank. Sorting handled this condition and LIS will handle south bank condition, right? 5 can of course come behind 6 because it's sorted on the basis of south bank, right? You can of course see, right, that south on the basis of south, if I'm talking about only the south bank, I'll not be selecting these two bridges, 3 with 5 comma 1. If I take 3 comma 5 with 5 comma 1, there will be a conflict. Although 3 is smaller than 5, but it is not forming an increasing subsequence in the basis of south bank, right? So what we are going to do, the solution for this problem is pretty clear. I hope that we are going to sort all these bridges or these pairs on the basis of north bank, and then we are going to apply longest increasing subsequence. We are going to find the length of the longest increasing subsequence on the basis of south bank, and this is how we are going to solve this maximum non-overlapping bridges. This, after sorting this on the basis of north bank and after getting the length of the LIS, which is 4, we'll get the number of bridges. You can see, right, because 1, 3 can be placed before 2 comma 4, can be placed before 3 comma 5, and it can be placed before 4 comma 6. These are the 4 bridges I can select, right? So the steps are pretty clear. I hope the steps of the algorithms I'll list here only. So first step is sort on the basis of what bank? North bank. Correct, north bank. Then apply LIS only on south bank. North bank will be strictly increasing because of the sorting, and since you are finding the longest increasing subsequence on the south banks, this means what? That you will be successfully able to get the increasing subsequence on the basis of south bank as well. I hope the problem is pretty clear to everybody. I know that this problem is a little bit peculiar because of the input they are giving us. Of course, these are the x coordinates which are given to us, north bank and south bank. Let us try to code this out quickly and then of course understand the problem in coding, like coding part as well, right? Let's get into it. So for this problem, I was not able to find any online judge, right? So I have created my own test case on VS Code only, right? These are the test cases we are having, right? Of course, this is the test case we saw, right? In the example, you can say when we were understanding, and expected output was 4, right? Of course, you can see in this test case, right? I can place 3 comma 4, and then I can place 5 comma 6. There'll be 2 bridges I can place, right? And this, of course, test case as well. I'll be having expected output is 2 only, right? Right. I'll tell you that how am I having these test cases in the VS Code only. I'm using extension, of course, right? I'll tell the name of the extension in the end of the video itself. Let's quickly first try to code this out. Let's quickly try to code this out. So basically, I'll write the Java code itself. So what I'm going to do here, I have to take an input of n and then I have to take two arrays of length n. Okay. So I'll take what? I'll take an array of n. I'll take an array of n. So integer n is equal to scn dot next n. Using the scanner only, I'll take the input, right? I've taken the input of n. Now what do I want to do? I want to basically find out like the two input the two arrays of north bank and south bank. So I'll just simply do this. So integer array, you can say north bank is equal to new integer n, and then I'll take the input for the north bank. So for integer I is equal to 0, I less than n, I plus plus. North of I is equal to scn dot next n. Then I have to take input on the basis of south bank. Integer south is equal to new integer n. Right, this is the south bank. For integer I is equal to 0, I less than n, I less than n, I plus plus. I will take the input for south of I, right, is equal to scn dot next, right. I don't want to miss any problem just because there is no online judge for that problem. This is a very famous problem, my friends, and it beautifully demonstrates the concept of longest significant subsequence and application of longest significant subsequence. We should, of course, respect these problems, and like I don't want it to skip this problem just because there is no online judge for this, right? So north bank, south bank, done. Okay, inputs, I've taken all the inputs, right? Now I have to bound the north of I with south of I, correct? Right. I have to bound north of I with south of I. You can say 2 can be connected to 6 only, right? So I'll create an array list. I'll create an array list of type pair is equal to ARR is equal to new array list, right? Of course, I'll define this class pair. So let's define this class pair. So public static class pair. And this pair class will be having what? It will be having integer north and it will be having integer south, right? Constructor pair integer north, integer south. This dot north is equal to north. This dot south is equal to south. I hope it is clear to everybody. I've created this class pair, right? Now for every ith, you can say index, for integer I is equal to 0, I less than n, I plus plus. ARR dot add new pair. I'll bound north of I along with south of I. I've bound them together. Now I'm having all these pairs together. The only thing now I'm going to do is sort ARR on the in ascending order on the basis of north bank. This was the first step. So collections dot sort ARR. Now Java doesn't know how to sort a custom class, right? And to sort the custom class, I'll create a lambda function, right? If you don't know what is a lambda function, of course tell me in the comment section. I can make a separate video on explaining lambda functions itself, right? And like if you already know, like I'll give you a small hint as to what are lambda functions here, right? Lambda functions help us to tell Java how to sort the particular data structure. Any data structure, it tells Java how to sort them, right? So array I've written, I'll add a comma. What is the syntax? I'll write a comma b in a bracket, arrow, and these curly brackets I'll write and I'll press enter, right? So this kind of thing I've written here. Now inside these curly braces, you can write any Java code you want. In short, I'm telling, if you want to sort this array in ascending order, you have to return an integer. Of course, you have to return a minus b. If you want to sort this on the basis of descending order, you have to return b minus a. We want to sort this on ascending order, I'll return a minus b. Return a minus b. But not just a minus b. I'll return this a and b. This a and b. What these variables will be having the data type of what your array list is of, what your data structure. It's of pair type. A will also be of pair type. B will also be of pair type. I want to sort this array in ascending order on the basis of north bank. So a dot north minus b dot north. You can of course tell me if it is not clear, right? I can of course make a separate video on lambda functions itself, right? But just tell me in the comment section like if you need this video or not, right? We can of course discuss this in detail as well. So I have just in this step I have just sorted this array list in ascending order on the basis of north bank. North bank is now sorted. Now only thing remaining is I will apply longest increasing subsequence on the basis of south bank. Longest increasing subsequence on the basis of south bank. Let us quickly do this, right? And to do this, I'll extract all the people from the south bank. After this array sorted, I'll extract all the people from the south bank, right? So, or we can do one more thing. Okay, I'll call this function lis. I'll just simply do system.out.println. I'll pass this arr here, right? Lis, in the lis function I'll pass this arr. Correct? I'll pass this arr. I have passed this array, and this function will get this public static int lis array list of pair arr. This function basically lis function public lis function will return the longest increasing subsequence of south bank on the basis of south bank. Correct? South bank. Correct. Now, so I'll of course apply the approach of n log n, longest and subsequence using n log n. We discussed this approach. You can of course find a pin to that video somewhere here only, right, in the I button itself, right. Let's try to discuss this. I'll directly write the code. I'll not go in detail as to how am I getting the longest and subsequence, right. You can of course look at that video because this is a follow problem to longest and subsequence. That is the prerequisite for this problem, right. So I'll take a tree set of integer ts is equal to new tree set, right, for pair p in arr. This is a for each loop. This array list is of type pair. This for each loop will one by one take all the pairs out in a proper order. Is this clear to everybody? This for each loop, right, will first get the 0th pair, then 1th pair, 2th pair out of this array arr, right. So I'll use this for each loop here, right, and you should of course explore these data structures which are of course you can say these lambda functions, these things, for each loops, these you of course you should explore at. So okay, integer south bank for this pair is what, p dot south, right. So I will try to find what integer ceil is equal to ts dot ceiling. I'll pass the south bank here, and if ceiling is not equal to null, right, I'll do what ts dot remove ceil, and then if it is like no matter what, if it's present or not, I'll simply do ts dot add south itself. Correct. I hope it is clear. In the end, I'm going to return ts dot size, and this is how we calculate the longest subsequence in n log n time, right. Let's try to run this code itself. So it's passing all the test cases, and this is the code for building bridges problem, right. You can say this thing what I'm using, it's called a cph judge. It's just an extension for lead code. Of course, you have to have Java installed in your system in order to run all these commands, like run this extension itself. You can of course write multiple test cases. This is of course a very good extension. You can of course try it out yourself. This is it for this problem, building bridges. I hope it is clear to everybody. The problem statement and you can see input type is a little bit peculiar, but yeah, I hope the problem is clear. On the basis of north bank, I'm sorting in ascending order. On the basis of south bank, I'm getting the longest in subsequence, and I'm doing so because I want to find out all the non-overlapping bridges. A pair of bridges is non-overlapping when n1 is smaller than n2 and s1 is smaller than s2. I hope this is clear to everybody. Thanks a lot everybody for joining. You can of course check out the code for this. I've provided the link in the description itself for GitHub. And yeah, I hope you're enjoying the series. Please like, share and comment below, right. We have just crossed 400 subscribers. I'm really happy for that, and next target is 500 subscribers, my friend. So please share these videos wherever you can, right, with whoever you can, right. And of course like the video and do comment and tell me that if you want any improvements, or if you want to know what are these lambda functions or how do we use this for each loops, these of course these types of things we also can discuss, right. So thanks a lot for tuning in. Until the next video drops.